Hi everyone, and welcome to the video lecture, The Science of Fire. This lecture video corresponds with chapter 12 of your textbook. In order to understand fire and explosive evidence, you have to have a clear understanding of how fire works. Fire is caused by a chemical reaction called an oxidation process that requires four elements. You need a source of fuel, a source of oxygen, and a source of heat. These are worked together in a chemical chain reaction to produce fire. The heat will heat up the fuel. What most people don't realize is that the fuel for fire is actually gaseous. Even though the fuels can be found within the scene in any state, they can be found as gas, liquid, or solid, it's actually only the gas vapors that burn. What happens is that the heat vaporizes the fuel, creating a gaseous fuel right above the physical fuel source. The gaseous vapors are then ignited by the heat and consume the oxygen in the air. As the fire continues to burn, it produces more heat, thereby creating more vapors on the fuel to ignite and then thereby consuming more oxygen. This chain reaction continues until one of the three sources is not present. The important end products of this chain reaction are CO2, called carbon dioxide, or CO, carbon monoxide. This graphic shows all four elements working together. Oxygen, heat, and fuel are all on top of the chain reaction. So long as these three remain present in a high enough degree in the area, it will sustain the chain reaction and the fire will continue. Lose any one of the elements and the chain reaction will stop and the fire will either be reduced or fully extinguished. Now, previously I mentioned that fire can produce either carbon dioxide or carbon monoxide. Although the difference between carbon monoxide and carbon dioxide is a single oxygen atom, this actually can make the difference between life and death. During the oxidation process, the carbon from the fuel attaches to the oxygen atoms, making the compound O2. Making the compound CO2. If the fire is burning well, it produces CO2, also called carbon dioxide, and that's a non-lethal byproduct of fires. This process of creating CO2 is called complete combustion. Now, sometimes, though, you end up with only one oxygen per carbon atom, and that results in carbon monoxide, and this is called incomplete combustion. Incomplete combustion occurs when there's not an even balance between the three elements. Most commonly, there's not enough oxygen in the air, so the carbon melds with the oxygen in single pairs instead of doubles. Carbon monoxide is a lethal byproduct of fire. In fact, your text mentions that carbon monoxide asphyxiation is the primary cause of death for most fatal fires. So why is carbon monoxide so lethal? The carbon monoxide molecule attaches to the hemoglobin in your blood and it sticks in your lungs on the oxygen receptors. So your body thinks you're transporting oxygen, but you're actually transporting carbon monoxide. As the diagram here shows, the oxygen and carbon dioxide molecules that normally get carried on the hemoglobin are turned away. The inability to transport oxygen through your blood causes you to suffocate. Now that we've talked about the chemical reaction that creates fire, let's talk about the three elements that create fire in more depth. First, fuels. Remember that a fire actually requires gaseous fuel. Before a fire can start, it must turn the liquid or the solid fuel into a gaseous vapor so that it can burn. Fire investigators call this characteristic volatility, or the likelihood that a fuel will support a fire under a given set of circumstances. There are three different measures of volatility for fuels, all of which relate to the transformation of the fuel into a gaseous state. The lowest temperature is the flash point. This is the temperature at which there is enough vapor on the fuel surface to become ignitable or combustible. Simply put, this is when enough of the fuel vaporizes into a gas so that the fire can be started using the gaseous fuel. The photo on this slide shows how the flash point differs between substances. The yellow liquid is gasoline, which has a flash point of 40 degrees Fahrenheit. The blue liquid is fuel oil, which has a flash point of 125 degrees Fahrenheit. The air temperature at 68 degrees in this photo means that The gasoline has ignitable vapors on its surface because it's above the gasoline's flash point, but the fuel oil does not have any vapors because the temperature has not reached that particular flash point. Fuels are classified as either combustible or flammable based on their flash point. Flammable liquids have a flash point below 100 degrees Fahrenheit. That means it's relatively easy to create enough vapors on the fuel surface to ignite, since temperatures under 100 degrees Fahrenheit are not uncommon or very difficult to produce. Combustible liquids, on the other hand, have a flash point above 100 degrees Fahrenheit. That means that they can create enough vapors on the fuel surface to ignite, but it's much more difficult to get them to ignite because it has to be warmer than 100 degrees Fahrenheit. The label here on the slide is the National Fire Protection Association Hazard Identification Symbol. You've probably seen this symbol before on laboratory buildings or chemical products. The goal of this symbol is to quickly alert first responders and emergency personnel about hazards within the building. The red box stands for fire hazard. The numeric value in the red box indicates the flame risk assigned based on flash point. As you can see from the legend, the highest number 4 indicates a very low flash point of below 73 degrees, and the lowest number 0 indicates that the item does not present a flame risk at all. Based on the flash points, flammable liquids would be classified as either a 4 or a 3, and combustible liquids would be 2 or lower. Now, another important characteristic of fuels is the fire point. Fire point is the temperature at which the vapors will sustain combustion. This means that the heat is high enough that the fuel will continue to produce enough vapors to stoke the fire continuously. Because fire point requires sustained combustion, the fire point is always a few degrees higher than the flash point. Now, the highest temperature is the boiling liquid. That's the temperature at which the liquid fuel vaporizes entirely. So let's transition to the other important element for fire, which is heat. Heat provides the energy to sustain the chemical reaction, mixing the fuel and the oxygen together. There are 5 potential sources of heat in fires. Chemical heat is produced by rapid oxidation process, like the heat from the fire itself. Mechanical heat is generated by friction, like when you rub your sticks together. Electrical heat is the result of the arcing or the shorting out of electrical power. Compressing a gas into a small chamber, that increases the molecular activity of the gas, and that creates energy that can create heat. And then lastly, you can get heat from nuclear energy, which results from the splitting of atomic particles. Regardless of the source, heat can provide energy to the fire by 3 methods. Conduction transfers heat through direct contact. In this diagram, you can see that the handle of the pot is getting hot. That's because the handle is in direct contact with the pot, so the heat has been transferred via conduction. Convection and radiation both produce heat through indirect contact. Convection generates heat by spreading the heat into a circulating medium, like the air or a liquid. The heated particles in the item touch the neighboring air particles and heat them, which then they touch their neighbors and heat them, and so on and so on. Radiation, on the other hand, travels through a medium, but it's the particles themselves that move through the air and send heat out. Think of this as like an X-ray system. The particles travel in a straight line out from the original source until they strike an object. You can see both of these heat transference processes in the boiling pot shown in this image. All right, well, that concludes the Science of Fire lecture video. In the next video, we're going to talk about the process of fire investigation.